All right, so we are actually, this is going to look a little strange, but we are doing what I'm going to call the pre-lesson 2-1. Because again, the information we're covering is from the 7th grade perspective, just to get your brains going, and then we're going to go from there. And yes, it is very dull. That's why we have half the lights out. The bulb is going, and hopefully we're going to get the bulb replaced, so the screen will get much brighter. Okay, bless you, bless you. So we're going to be talking about solving one-step equations with integers and rational numbers. Today's date is 11/2/15. So we're going to talk about a couple of properties that we're going to be using, and I'm just going to kind of outline them, and then we're going to talk about integer rules, and we're going to talk about reminders about dealing with fractions. So I believe our problems with our fractions are just adding and subtracting. So we're just going to focus in on adding and subtracting with the fractions. Tomorrow we'll talk about multiplying and dividing. And then we'll also talk about adding, subtracting, multiplying, and dividing, though I think maybe we're just adding and subtracting today. So I'm going to add that in here. So tomorrow will be multiplying and dividing, okay? So let's first talk about our properties, and they are called properties of equality. So anytime you hear of equality as part of a name, what that's basically telling you is that there's an equal sign involved, and what you're doing to your equation is equal to both sides of the equation, okay? So the key properties that we're going to be working with today are going to be the addition property of equality, and the addition property of equality states this: add the same value to both sides of an equation. Okay, so the addition property of equality says add the same value to both sides of an equation. So I'm going to highlight him in pink. The second one we're going to deal with is the subtraction property of equality. And again, that one says subtract the same value from both sides of an equation. Now, not only do these properties come to play in the problems that you're going to be dealing with, but which one we use is based on a different property, and that property name, he's going to be out of equality. Let's see, is going to be the inverse property of addition. So the whole premise for when we are solving equations is to get the variable alone, and to do that we do inverse operations. So today we're going to figure out if I have something that's being added to my variable, I'm going to do the inverse. I'm going to subtract that value from that variable. If I had something that's being subtracted from a variable, I'm going to do the opposite. I'm going to add to it. So that's where this idea of inverse property of addition comes from. And basically what it says is the sum, oops, so that means I'm adding, of opposites. So when I use the word opposites in math, I mean one positive, one negative. And when I add two numbers that are considered opposites, so they're the same number, but their signs are different, what do I always get? I always get 0, okay? So the sum of opposites is always 0. And what we're trying to do is get a number to disappear from one side, which means make it equal 0, and then reappear on the other side. And we can't just genie blink it and make it jump ship. We actually mathematically have to treat both sides of our equation the same. If we don't, we're going to have an issue. So before I do any examples, what I want to do is pull up one more thing, and that's rules. Okay, so today we're going to focus in on adding rules with signs. Okay, so integer rules for adding, okay, and subtracting. Everybody good here? Okay. So let's talk about integers. So I'm going to give you some scenarios, and then we're going to talk about what math would I do, and then we'll talk about what sign am I going to get. So with adding and subtracting, oh, Taj, did you not get something? Okay, hold on. Okay, so here's scenario 1. I have a positive, and I want to add it to a positive. What math do I actually do when I have 3 plus 4? Yeah, I just add, okay? What sign would my answer be? Not addition isn't a sign. It would be a positive sign. Okay, well, what if I have a negative plus a negative? What math would I do with those two numbers? Oh, I heard somebody say add. So the operation stays the same. And what sign would my answer have? Negative. Ben, you writing there, buddy? So if I had to come up with a general rule, in the top situation, both my numbers were positive. So they had the same sign. In the second situation, both of my numbers were negative. So they had the same sign. So when I have the same signs, I add the values. And then sign of answer matches sign of numbers. Ooh, matches. Which makes sense. If you're walking on a number line and you're positive, you're walking to the right, and then if you're adding another positive, you're continuing to go to the right and you're getting more. And then with negatives, you're facing left. And as you add another negative, you continue down the left path. So you're getting a negative answer. So again, same signs, add the values, sign of answer matches sign of numbers. So these two types of problems are very clear-cut. Same signs I add, my answer sign is going to match whatever signs my numbers have. That just makes sense. But when the scenario changes, and I now have a positive plus a negative, what math am I doing with them? I'm going to end up subtracting. the question then becomes, well, can I determine can I just say outright looking at that, bam, I know the answer is going to be positive, bam, I know it's going to be negative, and the answer is no. It takes a little bit more thinking. Now, the same scenario happens if I have a negative plus a positive. I'm going to subtract. So who can remember how you put a sign on your answer when you have different signs in your addition problem? Do you remember? Yeah, so, and it's kind of weird because you're saying, well, a positive number is always larger than a negative number, but we're physically just looking at the number, and we're not paying attention to the sign at first. So whatever number is physically larger, which would mean had the larger absolute value, then we're going to pick its sign to be our answer, because that's what we had more of. Kind of like when we were doing our exponents, wherever we had more of that base is where the leftovers ended up. Sometimes they ended up on the top, sometimes they ended up on the bottom. Okay, so the sign, this one, I can't determine the sign this way, so we're going to write it over here, and we're going to say different signs. We're going to subtract their opposites, in a sense, the values. And then sign of answer matches sign of larger value, of larger number, not value, of larger number. Larger value would include the sign. So we're actually thinking about absolute value at that point. Whoever has the larger absolute value would be considered the larger number. All right, so our directions are going to say, I'm trying to see what they write here, solve. Now I'm going to add this piece, check your answer. Make sure you understand what that looks like. So we're going to do some just with regular old integers, so I'm not going to put any decimals or fractions quite yet. So we could have something like x plus 3 equals 4. So I want to get x completely alone. So I'm looking at what's happening to the x, and what's happening to the x mathematically. What are they doing to the x? What's happening here? What are they doing to the x? They're adding 3. So what we want to do is not have the adding 3 there. So what we're going to do is the opposite, the inverse of that. So if I add 3 and negative 3, what do I get? 3 plus negative 3 doesn't equal 1.
0.
It equals 0. That's what I want. I want the left side to have a 0. So what I'm going to use is the subtraction property of equality. Okay, so subtraction property of equality. I'm going to do subtraction on both sides. What dictated to me what I needed to do was I needed to get the opposite value so that this became a 0. So it doesn't look like a 0. So what we end up with is x by itself equals, and then we do the math on the other side. What's 4 take away 3? 1. So my answer was x equals 1. Now, how do I check this? It's really simple. I take this value 1 and I substitute it in for x in the original problem and see if what I get is true. So I have 1 plus 3, and the question is, does that equal 4? So 1 plus 3 is 4, and 4 equals 4. So that verifies, yep, you did it right. Okay? So let's do one more like that, and then we'll go back to our notes. So let's have x plus, let's see, 5 equals negative 7. So again, we look at our original problem, and we say, what's happening to the x? Adding. So we need to do the inverse of adding, and the inverse of adding would be subtraction. So I'm going to subtract whatever is on the same side as the x. So I'm going to subtract 5 from both sides. And the whole point is that inverse property of addition says I'm going to get 0 for that sum, leaving me with x by itself. Now over here, I've got a -7 and a -5. Are the signs the same or different? Same. So do I add or subtract? Add. What sign does my answer get? Gets a negative because it matches the sign of the numbers. So I get -12. So remember what you could do with this? This means the same thing. If I have -7 take away 5, we have -7 plus -5. We can change any subtraction problem to an addition problem by adding the opposite, okay? And so it goes back to our addition rule. So we'll go back and add that in. All right, so again, to do a quick check, is -12 plus 5, does that equal -7? So my signs are different. Bigger number's negative. So I'm going to get a negative. 12 take away 5 is 7, and I get -7 equals -7. So that just verifies, yep, x has to equal -12. Okay? All right, so let's go back and let's talk about integer rules. I don't think I have any more space. Nope. So when I have subtraction, so subtracting with integers, we actually don't want to learn a new set of rules, so all we're going to do is a prep step, kind of like what a sous chef does, gets all the meal ready to go, and then you can just go ahead and cook, right? This is our notes. So for this one, when we have subtraction, so we have an x minus a y, what we're going to do is rewrite as an addition problem. Right, rewrite as an addition problem. How does that look? X doesn't change. But in order for me to rewrite as an addition problem, I have to make two different changes. And I think you guys, let's see if I can remember what you guys called it. I think you guys told me it was add a line, change the sign. Okay? So we add the opposite. So that's the change the sign, or add the line to make it add, and then add the opposite, and opposite is add a line. Okay? So this problem now is really x plus -y. So I actually never do a subtraction, a physical, it's with a minus sign in the problem. I change it to an addition problem, and then the sign attaches to the numbers. And that's really important that you guys see that, is that anytime you see a subtraction problem, it really is telling you it's an adding a negative number. You got to keep that in mind. And then what happens when you have this? What does x take away -y actually give you? Evan, boy, I got it out finally. Yeah, what happens is we're going to change the sign by adding a line. So let me rewrite the problem here. So we're going to make an addition, but then we have to make a second change, and that would be the sign. So this ends up becoming x plus y. Okay? So let's go back to the examples, and let's just do one simple one with that. Let's see, I don't have room there, so I'm going to go on my own. So you're back on the odds again. Third one. Let's say we have y minus 3 equals we can do it this way. So now I have a different one. So originally with a y, I'm subtracting 3, so I need to do opposite, the inverse operation. So what am I going to do to both sides? Say again? Not plus 5. Yeah, I got whatever's on the same side as the variable. He's my dictator. So I have plus 3 and I have plus 3. And then I just have to remember my rules. Signs are different. Bigger number's negative. Subtract. And I get my answer is negative 2. And again, our check can be real simple. We have a negative 2. Take away of 3, does that equal negative 5? And this is where I can do that change, where I add a line, change the sign, and now I'm adding opposites. I'm adding the opposites. So I get 2 negatives add up to give me a negative 5, and negative 5 equals negative 5. So that verifies I did it right. Okay. So if you think about it, any time that I'm solving an equation, let me go over here. Solving an equation. Yep, back on the note side. Do the inverse of the operation. So basically, our inverses are addition, subtraction. And the reality is they go both directions. Addition is the inverse of subtraction, and subtraction is the inverse of addition. Okay. So let's talk about let's talk about fractions and adding and subtracting. Okay, and they have together one set of rules. Say addition / subtraction of fractions. In order to add or subtract fractions, what do you need? What do you need? Do you remember? Yeah, that's the key thing right there. Denominators must match. So denominators must be the same. So if they aren't the same, you're going to have to figure out what the LCD is. So I'm just going to put some bullet ideas. Again, this should be familiar. So you look for the LCD, that's the least common denominator. And the reason why we go for the least is because then we most likely won't have to reduce answers down the line. And we're dealing with smaller numbers. So now that we have our denominators are the same, how do we actually physically add or subtract fractions? What does that really look like? What are we adding or subtracting? Oh, Piopolis, I know you know this. If I have two fractions, they have the same denominator, and I'm told to add them. What do I actually physically add? Simon? That's right. So we add or subtract the numerators only. So I'm going to double underline numerators only. We never do anything with the denominator, and that's the third thing. Denominator stays, the common denominator stays the same. So denominator remains the same because I've already taken care of in the first step that I have a common denominator. What's the only other thing we may have to deal with when we're working with fractions after we do math with them? What's the other thing that we have to look out for? Okay, Danielle? Yeah. Simplify fraction answer if possible. And by simplify, that means dividing by the common denominator or common factor, It does not mean change it to a mixed number. It does not mean change it to a decimal. An fraction is an exact answer. A repeating decimal is an estimated answer. So far better to leave your answers as improper fractions than trying to figure out what the answer is as a decimal. Also far better just to leave it as a regular fraction. Don't go to decimals. Okay? All right, so let's do a couple problems like that. So we have x plus 1/2 equals 3/8. So the first thing that I would do is to determine what math I would need to do to get my variable alone. That's going to be my first best step. Okay, so what do I need to do to get x by itself? How do I get rid of the plus 1/2? I'm going to subtract 1/2 from both sides. So now what I have for a problem, because this gives me 0, what I have now is 3/8 take away 1/2. But I can't do that because they don't have the same denominator. So what I'm going to have to do is to create what we call equivalent fractions. They need to have the same denominator. So what's the least common denominator between 8 and 2? 8. Now if you notice, 8 on the top is the same as what I had to begin with, so that fraction stays exactly the same. I didn't have to alter it at all. But the second one I do have to do some altering. It took me 2 times 4 to get 8, so I'm going to multiply the top also by 4. And -1 times 4 is -4. So now my problem is 3/8 take away, or 3/8 take away 4/8. So this becomes adding opposites. So I have x alone over here, which is what my whole goal was. And now I'm going to do 3 take away 4. The denominator is going to be 8. Okay? So if you have trouble with the problem the way it's written, change the subtraction problem to an addition problem. Add the opposite. Okay? So what's 3 plus -4? So your answer is the missing number was -1/8. And you can check that. And that's going to give you -1/8 plus 1/2. Does that equal 3/8? So to check this gets a little messier because now I need to convert 1/2 into a fraction with a denominator of 8. And I have -1 plus 4 is 3. And sure enough, I get exactly what I need. Okay? And then, everybody good? Let's go over here. More examples. Now, we just dealt with decimals. What's the key about adding and subtracting decimals? How do you do that? We did it a ton with our scientific notation. So let's see, what example are we on? 5. So if I have y minus 13.2 equals 1.57, what am I going to do to get y alone? I'm going to, say again? No, subtracting and subtracting signs would be the same, and I would add. So I need to do opposite signs. But how do I write the plus 13.2 on the other side? What do I have to remember to do? Sophie? Gotta line up my decimal points. So we're going to line up decimal points. And what's the second thing that we need to do? Yeah. Fill up spaces with zeros. Okay. Now I'm adding on both sides, so my signs are the same, so I'm just going to go ahead and add. And let's see, I get a 7, there's my decimal point, 1 and 3 is 4, and then I get a 1. And I get y equals 14.1. So again, I can check, is 14.77 is 14.77 minus 13.2 actually equal to 1.57. So I'm going to line up decimal points, add to the 0, and do the math. So I get a 7, I get a 5, I get a 1, and that matches exactly with what it said I should be getting. So that verification that I did it right. All right, so one last type of problem. Make sure that you guys don't get confused by this. What if the problem looks like this? Now, what's going to be part of my answer? What has to be part of my answer? R. Now, where does R show up in my answer? In the front or in the back? Okay. Where should it be, though, when I finish? In the front. So we actually have a property called the symmetric property, which says if you have an equation and you don't like the way it's written, you can rewrite the equation by picking up the right side and put it on the left. Pick up the left side, put it on the right. So in other words, this is going to go this direction on the equals, and this is going to go this direction. And you don't switch what's on a side, you just switch an entire side. Because your answer should always have a format, variable equals number. Okay? So I'm going to write that, answer format. Okay, so here's some deals. When we're doing work, you have to show what you're doing to get your variable alone. You have to show what's being added or subtracted from both sides. You have no choice in that. You also need to make sure that your variable is part of your answer because this equation was demanding that you solve for R. So you need to give back that R as part of the answer. I'm looking for this when you guys are taking a quiz. You'll be taking one next Tuesday, so I look for all of this work. That means on Thursday works coming up, what I may say are things like, what was the, what math did you do to both sides and with what number in order to get the answer? So now I'm not saying what's the original problem. Now I'm looking at your physical work. And then I may have a question is, what was the variable that was part of the answer on this question? That needs to be there too, okay? So what math am I going to do to get R alone? I'm going to subtract because that's the opposite of adding. And what am I going to subtract from both sides? I have a little whisper over here. Whatever's on the same side as the variable. Oh, that's a terrible color for this bad screen. Here, let me darken that up. I'm going to subtract 3 from both sides. So the 3, positive 3, negative 3, 0 out, leaving me with just R. And then what's 7? Take away 3. And the answer is 4. And then 4 plus 3 is 7. 7 equals 7, so it makes sense. Okay?